Welcome to EDU World Space.
In problem 90, we're asked to prove that when you have two thin lenses in contact with focal length f1 and f2, that the combination of the two lenses give you a new focal length, which is 1 over f. That's equal to 1 over f1 plus 1 over f2. And in part B, we're told that we have a meniscus converging lens with an index of refraction of 1.55 and the radii of curvature given as 4.5 and 9 centimeters. And the concave surface of the lens is turned upwards and filled with a liquid, which is carbon tetrachloride. And this has an index of refraction of 1.46. And we need to find the focal length of this liquid and solid lens combination. So obviously we're going to use the results of part A in solving part B. So let's proceed to solve part A. We're going to use equation 34.16, and the idea is to use this equation twice, because we will note that the image that you get from the first set of lens will act as the object for the second set of lens. So we have, let me go and draw a picture first before I set up the equation. So let's say we have the optic axis, which should be straight. And then you have an object here, a lens here, the image from the first object, a lens here, and another image. And so let's say this is S1, and this is S1 primed. Okay. And then this will be S2. And this will be S2 primed. And then let's say the distance between the two lenses is given by D. Clearly, D is equal to S1 prime plus S2. And we can do a little bit of rearranging and say S2, which is the object for the second lens, is D minus S1 prime, which is the image. So the object for the second lens, S2, is the distance of separation between the two lenses minus the image formed by the first lens. Now we're told from this problem that the two lenses are in contact. So D is 0. Therefore, in this particular case, S2 is minus S1 prime. And this is an important result to keep in mind. So like I said before, we're going to apply equation 34.16 twice. And so that is, we're applying this equation for each one of the lenses. So we'll begin with the first lens, and we'll have this index 1 to denote that we're talking about the first lens here. So what we'll do now is find the image here in terms of S1 and F1. So that's simply 1 over S1 prime is equal to 1 over F1 minus 1 over S1. Okay, so that's from our first use of equation 16, and now let's apply it to the second lens. So 1 over S2 plus 1 over S2 primed is equal to 1 over F2. Now, I mentioned before that S2 is minus S1 primed, right? And we found that S1 primed is equal to, over here, 1 over S1 prime is equal to 1 over F1 minus 1 over, so I had from that previous equation that 1 over S1 primed is equal to 1 over F1 minus 1 over S1. So what we're going to do is substitute for 1 over S2 using these two equations. So 1 over S2 is equal to minus 1 over S1 primed. And S1 primed is given by, so let me put that negative sign over there and substitute for 1 over F1 minus 1 over S1, which is equal to 1 over S1 minus 1 over F1. Okay, so now we can use this result and substitute it here. And for 1 over S2, so 1 over S2 is 1 over S1 minus 1 over F1 plus 1 over S2 primed is equal to 1 over F2. And now I will move 1 over F1 to the right side, so that gives me 1 over S1 plus 1 over S2 primed is equal to 1 over F1 plus 1 over F2. Now, this is starting with an object, to the relative to the first lens, and then I have an image that's relative to the second lens. So that should be 1 over F, the focal length of the whole system, right? So that tells me that 1 over F is equal to 1 over F1 plus 1 over F2, which is the desired result. So let's now use this to address part B of the problem, right? So in part B, we have some meniscus lens with an index of refraction and the radii of curvature. So we're told that it kind of is turned up like this. And let me call the index of refraction with an M for the meniscus lens, which is 1.55. And then it's filled with some liquid here. Let me call that NC for the carbon tetrachloride, which is 1.46. And we have R1 is 4.50 centimeters. And then we have R2 is 9.0 centimeters. And we're asked to find the focal length of this combination, right, of this solid lens and this liquid lens together. And as I said before, we're going to use 1 over F is equal to 1 over F. Instead of 1, let's call it Fm plus 1 over Fc, right? So Fm is the focal length of this meniscus lens and Fc of this liquid lens. So we need to find the focal length of each one of these individually and then add them up. So to do that, we're going to use equation 34.19, which is called the lens maker equation. And that tells me that 1 over F is equal to n minus 1 times 1 over R1 minus 1 over R2. So let's do the meniscus lens. So I'm just going to write M to say that we're working on the meniscus lens. So that tells me 1 over Fm is equal to Nm minus 1, 1 over R1 minus 1 over R2. So in this case, this is going to be my R1 and R2 over here, and Nm is 1.55. So let me substitute the numbers. And this gives me a focal length of, when I substitute these numbers and then take the reciprocal, then I get a focal length of 16.36 centimeters. And in a similar case, I could do it for the carbon tetrachloride. I just substitute the appropriate numbers. Okay, and now, so for the carbon tetrachloride, the R1, the first radius is going to be 9 centimeters, right? Because that's over here. So that's, as you can see from the diagram, so that's 1 over 9 centimeters. And R2 now is this flat surface. But when you have a flat surface that has an infinite radius of curvature, which when you divide by infinity, you get 0. And if I take the reciprocal here, then I get 19.57 centimeters. And then for the total focal length, I use the result I found in part A, and I have FM and FC. So if I substitute those numbers in there and take the reciprocal, then I get 8.91 centimeters.